Bicing paper number 5. First question given here is select a species or name which is inappropriate for the thing mentioned within brackets in front of the following list. You have to select only one answer. That answer should be inappropriate answer for the question. And write in the given blank. The first one, Stoney, Thomson, Rutherford, Bohr, and Heisenberg. Scientists who directly contributed to introduce models of atomic structure. So you have to select inappropriate answer. Scientists who directly contributed to introduce a model of atomic structures, Thomson, Rutherford, Bohr, and Heisenberg. All these 4 persons have contributed some amount to discover the correct structure or model structure of the atom. So inappropriate answer is Stoney. Stoney just said about the electron, right? Electron. So answer should be Stoney. Next one, N3 minus, NO2 plus, carbon dioxide, I3 minus, and N2O. Electron pair geometry around the central atom of the molecule is similar to geometrical shape. Electron pair geometry shouldn't same with shape, right? Geometry and shape. Question asks, what is the anion or molecule which has different geometry and different molecular shape? So you have to draw before getting the answers. N3 minus. Question number 1A, Roman number 2. N3 minus. Structure for N3 minus. We have 3 nitrogen atoms. Valence electrons is 5. 3 into 5 is 15. With the negative charge, total electrons around N3 minus are 16. So you can add double bonds to complete the octet. Then 2, 4, 6, 8, 10, 12, 14, 16. So there is a negative charges on surrounding atoms and plus charge on central atom. So both geometry and shape is linear. Both geometry and shape is linear. NO2 plus also has same shape and geometry. It also linear. Both shape and geometry is linear. Then carbon dioxide. With experience, you know carbon dioxide also have same shape and geometry, that is linear. Carbonate. Carbonate is different one. Sorry, I3 minus. I3 minus have different one. I3 minus. So central ID, atom mass 3 lone pairs with the negative charge. So shape is linear. But geometry is trigonal bipyramidal due to 5 whispers around the central atom. N2O also have same linear and linear for geometry and shape. These are the answers. So inappropriate answer should be I3 minus, I3 minus. Please note down. The next one, hybridization of carbon atom in sp2, sp2. So you have to select the molecule which has a different hybridization than sp2. So with the experience, no need to write all answers given for here. HCHO, formic acid, it has 3 whispers around the carbon atom. Due to that, sp2. C2H4 also has sp2. Carbonate also has sp2. Oxalate also have sp2. But carbon monoxide has only 2 whispers around the carbon atom. Therefore, sp hybridization. So, inappropriate answer should be carbon monoxide. If anyone wants to note down that, right? If you more explanations, please send a message. So I'll explain it. Molecules has a permanent dipole moment. So you have to select the molecule which has not permanent dipole moment. So simple, that is carbon disulfide. Because carbon disulfide same as carbon dioxide. Carbon dioxide, right? Carbon dioxide, that is. 2 sulfur atoms surrounding. Therefore, dipole moment from carbon to sulfur atom. Carbon to sulfur atom. Same process, opposite direction. They get cancelled each other. The next one is strong hydrogen bonds are formed between the molecule in the given mixture. So you have to select the answer which has no strong, which has no strong hydrogen bond between. So ammonia and nature is strong. HCl, CH3OH should be the answer because HCl is dipole-dipole interaction. CH3O, CH3 is just London forces. Therefore, they have different types of secondary interaction and their attraction also very weak. Answer should be HCl and CH3O, CH3. Right, let me know anyone who got all correct answers for the part A. Put the marks. The correct answer, for the correct answer, 5 marks. 5 into 5, 25. Anyone who got 25 out of 25? Anyone, please? Very good, Tevni. Right, one of the your friend has got 25 out of 25. Very good. Right. Then to the part B. Part B. Hurry up. Within 4 minutes, 5 minutes, you can get the answer. Right. So because for the structured part or the time period for the structured part is 15 minutes. A part, B part, C part, 5 marks for A part, 5 marks for, 5 minutes for A part, another 5 minutes for B part, and another 5 minutes for C part. Right? So the question has only A, B, C part. Therefore, you have to write answers for the sub part of the question within 5 minutes. Hurry up. Right, B, formaldehyde. Formaldehyde. What is formaldehyde? 8C double bond O8. You have learned this molecular, right, molecule in secondary interaction, right? Dipole-dipole interactions. We take formaldehyde to give the example for the molecules which has dipole-dipole interaction. Formaldehyde and semicarbazide. Semicarbazide should have a different one. 1C, yeah. CH5, semicarbazide, skeleton given 2 nitrogen atoms, 1 carbon, 1 oxygen, and another nitrogen atom. React together form semicarbazole. Semicarbazole, right? So we have molecular skeleton for the semicarbazole too. Skeletons of semicarbazide and semicarbazole molecules are given below, and there is no hydrogen atoms bonded with oxygen. So hint is there is no hydrogen atom bonded with oxygen. Means you have to draw double bond in between carbon and oxygen to take the zero formal charges on oxygen atom. So here double bond in between carbon and oxygen. When we join double bond, we have zero formal charges on oxygen atom. Draw most acceptable Lewis structure of formaldehyde, semicarbazide, and semicarbazole molecules in the following boxes. So this is the formaldehyde. Here, the total hydrogen atoms in semicarbazide is 5 hydrogen atoms. 5 hydrogen atoms. So we can take 2 hydrogen atoms in between these two, this nitrogen atom, and we have 3 more. We can take 2 for the corner nitrogen atom and another hydrogen for this nitrogen atom. So to complete the valencies on each nitrogen atom, you have to put 1 lone pair on each nitrogen atom. And semicarbazide molecule is C2. Yes, we have C2, H5. H5. 1, 2, 3. Right? You can see when we compare these two structures react to form the carbazole. Right? So the corner nitrogen doesn't change. Carbon is in carbazide doesn't change. This nitrogen and hydrogen doesn't change. There any difference, right? Any changes can be seen with this part of the molecule and this part of the molecule. So you can see oxygen and 2 nitrogen atoms have removed from the molecule as a water molecule. Therefore, this carbon atom has 2 hydrogen atoms. To complete the valency, we have to make the double bond. And here, 2 lone pairs on each nitrogen atom. So that should be the correct structure. There's no any other option to draw this structure. We have 5 hydrogen atoms. So to complete the valency of each nitrogen atom, the nitrogen form maximum 3 bonds now without formal charges. Without formal charges, nitrogen can form maximum 3 bonds. Right? To take the 0 formal charges from 5 hydrogen atoms, connect 2 hydrogen atoms to each most corner nitrogen atoms. The remaining nitrogen atoms connected with the second nitrogen atom. That's how molecule is obtained. Got it? So these are the skeletons and correct Lewis structures. Take marks for 5 marks for the correct structure, totally 15. The A part, you have 25 marks. B part 1 has 15 marks. Right, then atoms in semicarbazole molecules are numbered according to following manner. So semicarbazole, hydrogen, carbon, hydrogen, double bond nitrogen, single bond nitrogen, carbon, double bond with oxygen, here nitrogen, here hydrogen, hydrogen. So they have labeled this carbon as number 1, here number 2, here number 3, number 4, and 5 oxygen and 5 nitrogen. So you need to complete the table given below by considering C1, N2, N3, and C4. Vesper units, 1, 2, 3, 1, 2, 3. 3 Vespers around 1 carbon, first carbon atom. Here 1, 2, 3, 1, 2, 3, 1, 2, 3. So 3 Vespers around this nitrogen 2. 1, 2, 3, 4, 1, 2, 3, 4. 4 Vespers around the N3. And here 1, 2, 3, 1, 2, 3, 3 Vespers around the carbon labeled as 4. Electron pair geometry. 3 Vespers trigonal planar. 3 Vespers trigonal planar. 4 Vespers tetrahedral. 3 Vespers trigonal planar. Shape. There is no lone pairs around the carbon atom. Therefore, both geometry and shape take as trigonal planar. Around this nitrogen atom, 3 Vespers, including 1 lone pair and 2 bonded Vesper pairs. Therefore, shape is angular. This one has 4 Vespers, 3 bonded pairs and 1 lone pair. Therefore, trigonal pyramidal. Trigonal pyramidal is the shape. This carbon atom has no lone pairs, just bonded pairs as a Vesper pairs. Therefore, trigonal planar. Trigonal planar. Hybridization. 3 Vespers sp2. 3 Vespers sp2. 4 Vespers sp3. 3 Vespers sp2. Oxidation number. Oxidation number. For the lower electronegative element, take +1 due to 1 bond. Here -1. Here +1, -1. Due to double bond, +2, -2. Overall charge around this is 0. That is the oxidation number. This nitrogen takes 0 charge due to nitrogen single bond. So overall charge here is -2. Here -1 +1 due to NH bond. Due to NC bond, +1, -1. Sorry, -1 +1. So overall charge around this also -2. Here, -2 +2. -1 +1. So overall charge around this carbon is +4. These are the oxidation numbers. So total marks for this, 5 times 4. 20 marks. 20 marks. 20 marks. Identify the atomic or a hybrid orbitals involved in forming Philippian sigma bonds in the Lewis structure semicarbazon drawn in part 1. Right. This one is atomic orbital. This one is sp2 hybridized orbital. This one sp2 hybridized orbital. This one sp3 hybridized orbital. This one sp2 hybridized orbital. So when you write in hybrid or atomic orbitals involved in forming sigma bonds or pi bonds, you have to mention whether it is hybrid orbital or atomic orbital within the bracket. Right? So this bond formed by one is atomic orbital, sp2 hybridized orbital. These two bonds form sp2 hybridized orbital, sp2 hybridized orbital. These two form sp2 hybridized orbital, sp3 hybridized orbital. These two form sp3 hybridized orbital, sp2 hybridized orbital. So total marks for that part is 2 times 5, 10. 10. And then ask Identify the atomic cohydride orbitals involved in forming following sigma bonds in the Lewis structure. Write sigma bond. No, it should be 5 bond. I'll give 2 minutes. Please write the answer again. Identify the atomic cohydride orbitals involved in forming. Yeah, 5 bond, not sigma bond. It should be 5 bond. Please do it again within 1 minute. Finish. Right, always 5 bonds formed by overlapping p orbitals parallel to each other. P orbitals. So both oxygen and carbon belongs to second period and they have 2p electrons in outermost energy levels for making bonds. Therefore, carbon has 2p atomic orbitals. Nitrogen also have 2p atomic orbitals. Carbon, again 2p atomic orbitals. Oxygen, 2p atomic orbitals. So 2 into 4, 8 marks. 8 marks for that part. Right, the last part. Within 5 minutes, please take the answers for part C. Hurry up. Part C. If you have any doubts, please send a message. Got it? Right here, first set of quantum numbers of an electron is an atom are given below. See, first one is 400 plus half, that is 4 is 1. B 3p minus 1, 0 plus 1. So here minus 1, 2, 3, 4, 5, 6. Plus 1 minus half is 2p6. 2p6. C 3d minus 2 minus 1, 0. 3d3. D 3s2. Arrange A, B, C, D quantum numbers. It will increase in order of energy. That is Sackler principle. So highest energy on C. Then A, B, D. Right. 7 marks. 85. Arrange the species CH4, SO2, C2H5 is in increasing order of boiling point and give the reasons for your arrangement. Highest boiling point on C2H5 OH, then SO2, then CH4. For the correct answer, 5 marks. For the explanation, 10 marks. You have to write CH4 has only London forces. SO2 has dipole-dipole interaction. C2H5 has hydrogen bond. So bond is strength. You have to write all these 3 types of bonds. 2, 4, 6 marks for that. Then write bond strength, secondary bond strength. Highest in hydrogen bond than dipole-dipole interaction. Dipole-dipole interaction has highest value than London forces. To write that sentence, 4 marks. That's why boiling point increase according to this rule. So put the marks out of 100. Then move to, don't we have second question? 1, 2, 3. Only 3 questions given, right? Question numbers are different. Right. Please let me know. Please tell me whether you have, the people who are not coming for my theory classes, tell me whether you have completed third unit, chemical calculations. Because if you know the chemical calculation theory, you can't get the answers for 3A and 3B. Anyone? 3A and 3B. You all have done? Right, okay. So we can continue. Right, please read question number 3, right? It should be 2, but it will state the number, question number given as 3. 3 part A. Oh. Because most of you have guys completely done third unit now, therefore I have to continue the lesson. Question. Right. Please try to catch up with the questions. Right, please read. I'll explain how to get the answer because I know most of you guys may not, right, know how to get the answer for this. Right, read 3A, part 3A. I'll explain each. Ma kemati putala marks ke na out of 100. Maki theory class then okkomudalu right? YC paper 6 venaka. Right? The next Tuesday 6 karna na yoga classes till Friday and Saturday ne theory classes enokota YC paper 6 venaka repeat karagina red pen nekin check karla marks dagin mata files adala genap dennone mark sheet take up to YC paper 6. Right, this paper, these questions taken from 2018 Devi, right? Okay, Dinit. Devi Balika Girls School, right? You can see the questions given here is complete, not much difficult, but they have complicated questions. 2018, as I remember, 2018 Devi, right? Day 12 first term. Right. The third one, it should be second one, but here mentioned as 3. 10 grams of sample. 10 grams of sample containing magnesium chloride and calcium carbonate was dissolved in 200 cubic centimeters of 2 moles per decimeter HCl solution. Then this solution was diluted up to 250 cubic centimeters by adding distilled water. 25 cubic centimeters portion of this solution was reacted with 1.0 moles per decimeter sodium hydroxide solution. Volume of sodium hydroxide spent was 35.50 cubic centimeters. Calculate the mass percentage of calcium carbonate in the sample. You need to get the calcium carbonate. Right. Think simply. You have a mixture. Right? You have a mixture. You have a bucket. And it has a, right, you may have a beaker and it contains some amount of magnesium chloride and calcium carbonate. Magnesium chloride and calcium carbonate. The total mass given as 10.0 grams. But we don't know the actual masses separately for magnesium carbonate and calcium carbonate. We know the sample. the total mass of the sample. Total mass of the sample of magnesium chloride and calcium carbonate. You need to calculate mass percentage of calcium carbonate. To get the mass percentage of the calcium carbonate, they have done some experimental test. As a first part, they have added 2 moles per decimeters HCl. 2 moles per decimeters HCl to the sample. Right, you have 2 compounds now, magnesium chloride and calcium carbonate. When we add in HCl, HCl is an acid. First, you need to take from magnesium chloride and calcium carbonate, which one is reacted with HCl. Or you have to select from those samples, those compounds, which one react with HCl, or both, whether both compounds react with HCl. So magnesium chloride, HCl. Magnesium chloride is neutral compound, like sodium chloride. Therefore, it's not going to react with HCl. So same anions, chloride, 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 chloride. MgCl2, it has chloride. HCl also have chloride. So magnesium chloride and HCl reaction is double displacement reaction. Double displacement reaction. So we have to exchange their cations and anions. Magnesium chloride formed by Mg2 plus and Cl minus. HCl formed by H plus and Cl minus. So when we exchange in their charges, cations and anions, again we have magnesium chloride and HCl. Therefore, first hint, the magnesium chloride does not react with HCl. And what happened to calcium carbonate? If magnesium chloride doesn't react with HCl, remember that calcium carbonate should react with HCl. Calcium carbonate should react with HCl. So first write the chemical reaction. Magnesium chloride, right? You know that. My students know that. This one is aqueous, physical state is aqueous. HCl also aqueous. There is no reaction take place in between these two. Calcium carbonate, it's a solid. React with acid, giving, right? Double displacement reaction. Calcium combined with chloride to give us calcium chloride plus carbonate, right? Carbonate combined with hydrogen as a carbonic acid. Calcium 2 plus CO3 2 minus H plus Cl minus. So calcium chloride and H2CO3. H2CO3 is weak acid. Therefore, it's not stable and again dissociated to carbon dioxide and water. Carbon dioxide and water. CO2 gas and water. So after adding HCl, we have magnesium chloride, means it doesn't react, just magnesium chloride, calcium chloride, carbon dioxide and water. Calcium chloride, carbon dioxide and water. Only one compound from magnesium chloride and calcium carbonate react with HCl, that is calcium carbonate. Clear? Okay. Then dilute the top of distilled water by adding distilled water. The distilled water is just water. Water gives H plus and OH minus. When we add in water, it doesn't affect to change the total moles of main components. Just dilute. Just increase the volume. Increase the volume. And it goes to decrease the concentration. Decrease the concentration because total number of moles doesn't change. Concentration is equals moles over volume. When volume gets increased, total concentration of the solution will decrease. Therefore, even we add water, the total solution has same amount of initial compound and it doesn't change. Then, after this, so here, so after adding water, again we can CO2 remove as a gas. Water does not affect. Calcium chloride also neutral. So we have MgCl2, calcium chloride, carbon dioxide evaporate, and H2O liquid. All these three are neutral salts. Magnesium chloride, calcium chloride, water. All these three are neutral salts. But after in water, there's another reaction with sodium hydroxide. Sodium hydroxide is a base. Sodium hydroxide is a base. Always base react with amphoteric compounds or acids. Always base react with amphoteric compounds like beryllium hydroxide, aluminium hydroxide, aluminium oxide, something like that. If there is no amphoteric compounds like amphoteric oxides and nitroxide, then bases should react with acids. But here, do we have any acids? We have magnesium chloride, calcium chloride, and water. So we don't have acids. Do we have? After the reaction in between magnesium chloride and calcium carbonate with HCl, we have magnesium chloride because it doesn't react with HCl, calcium chloride, carbon dioxide, and water. These are the things we have. But the problem is the things we have after the reaction in between acid, we should have acids to react with base. Means you have added HCl in excess amount. You have added HCl, excess amount. After the reaction, some amount of HCl remaining in the solution. After the reaction, some amount of HCl remaining in the solution. Therefore, addition to these three, there is some amount of HCl. Some amount of HCl. To get the amount of HCl remaining after the reaction with magnesium chloride and calcium carbonate, we have to do another test to get the HCl. So the remaining HCl after the first reaction react with sodium hydroxide here. So sodium hydroxide, the third reaction, sodium hydroxide react with HCl, again double displacement reaction, giving sodium chloride and H2O. Right, these are the reactions take place here. So now you can get the amount of calcium carbonate in the initial sample. So first you need to take the moles of sodium hydroxide. Here's the flow chart. Take the moles of sodium hydroxide first. When you know the moles of sodium hydroxide, according to stoichiometric ratio, you can get the moles of HCl unreacted with calcium carbonate. Unreacted with calcium carbonate. And there is another data. What is that? The initial added HCl. You can get the moles of HCl initially added. So from these two, you know the amount of moles of HCl initially added and moles of HCl unreacted with calcium carbonate. So the difference between these two is the moles of HCl reacted with calcium carbonate. Moles of HCl reacted with calcium carbonate. So when you know the moles of HCl reacted with calcium carbonate, from that you can get the moles of calcium carbonate in the sample. Right? You can get the moles of calcium carbonate in the sample. Right? In the sample. So when you know the moles, you can get the mass of calcium carbonate. Then finally take the mass percentage of calcium carbonates. That's how we can get the answer for this. Right? කලබල වෙන්න එපා පුතාලා. කලබල වෙලා ප්‍රශ්න ගන්න බෑනේ. ඔයාලට මේක එකපාරටම තේරෙන්නේ නැහැ. ටික ටික කැල්කියුලේෂන්ස් කරලා තමයි ප්‍රැක්ටිස් එක ගන්න ඕනේ. වෙන්නේ මොකක්ද කියලා ඔලුවට ගන්න. මම තියරි ක්ලාස් එකේ මේ තියරි ක්ලාස් එකේ ඔක්කොම right 6 lesson එකේ ගන්නවා මේ chemical reactions වලට ඕගොල්ලන්ට ඕනේ කියලා එක. ඒවත් එක්ක idea එක ගත්තාම මේ calculations simply ගන්න පුළුවන්. right මේක ලියා ගන්න අපි ගාන හදමු. Right. Start with sodium hydroxide moles. Right. How to write? You know how to write. Number of moles of 1.0 moles per deciliters. Sodium hydroxide in 35.50 cubic centimeters equals 1.0 moles per deciliters into 35.50 cubic centimeters over 1000. So here 3.55 into 10 to the power minus 2 moles. So this is the number of sodium hydroxide. So then from stoichiometric ratio, 1 moles of sodium hydroxide reacted with 1 moles of HCl. Therefore, number of moles of HCl unreacted with calcium carbonate in 25, because the three separated only 25, right, is 3.55 into 10 to the power minus 2 moles, right? Unreacted mole is not valid. Then take the moles of HCl initially added. Moles of HCl initially added. Shall I erase? Number of moles of 2 moles per decimeters HCl in 200 cubic centimeters. Right? 200 cubic centimeters. 2 moles per decimeters into 200 cubic centimeters over 1000. Here's the initially added amount. 0.4 moles. But this amount, 0.4 in 250. Right? The total HCl in this here, 0.4. The initially added amount is 0.4. 0.4. The initially added amount is 0.4. 0.4. So if we assume that 25 HCl, 25 cubic centimeters has 3.55 into 10 to the power minus 2 moles of HCl, you have to take the total moles of HCl is 250. Right? 250. Right? 250. Therefore, moles of HCl unreacted with calcium carbonate in 250 cubic centimeters. Number of moles of HCl unreacted with calcium carbonate in 25 cubic centimeters has calculated as 3.55 into 10 to the power minus 2. But you need to take in the 250. If 25.00 cubic centimeters has 3.55 into 10 to the power minus 2 moles, the amount in 250 cubic centimeters is 10 times of this, that is 3.55 or 0.355 moles. So now we know initially added amount is 0.4, unreacted amount is 0.355. So the difference between these two is the amount that do not react with, the reacted amount with calcium carbonate. Therefore, reacted amount of HCl with calcium carbonate is initially we got 0.4 moles, reacted amount is 355 moles. The difference between these is 0.045 moles. That is the reactant amount. Reactant amount is this one. 0.045 moles is the reactant HCl with calcium carbonate. To balance the reaction, you need to multiply this by 2. This by 2. 2 of HCl reacted with 1 moles of calcium carbonate. Then here, one moles of calcium carbonate reacted with 2 moles of HCl. Therefore, moles of calcium carbonate in 10.0 grams is the total HCl reacted is 0.045 moles. The stoichiometric ratio is 1:2. We need to take calcium carbonate moles from HCl. Therefore, you have to multiply this by half. 0.0225 moles. When you know the moles, you can get the mass by multiplying the molar mass. Molar mass of calcium carbonate is 40 plus 12 plus 16 into 3 grams per mole, that is 100 grams per mole. In each step, write units. When you write in any chemical reaction, write the physical states. Lazy. Right? Therefore, mass of calcium carbonate is 0.0255 moles into 100 grams per moles. That is 2.55 grams. The answer you got here should be less than 10 because total mass of the sample is 10, no, right? Therefore, only the mass of calcium carbonate should be less than that. Then take the percentage. Shall I erase this part? Therefore, calcium carbonate percentage is 10 grams contain 2.55 grams. Therefore, 100 should contain 25.5%. This is the final answer. Clear that? තේරුණාද පුතාලට? Confused වගේද? කියන්න බලන්න. අයියෝ හරිම අමාරු ගානක්, හරිම complicated. මේක තේරුන්නේ නැහැ. දෙන්න බලන්න කමෙන්ට් එකක්. තේරුන්නේ නැහැ කියලා තේරෙන එකත් ලොකු දෙයක් පුතේ මෙච්චර වේලපහ. ගොඩක් දරුවන්ට මේවා තේරෙන්නේ තව අවුරුද්දක් එකමාරක් ගියාට පස්සේ. third unit එකත් ඉවර වෙලා ගොඩක් classes වල අමාරු calculations කරන්නේ නැහැ. මොකද එතකොට ළමයි එන්නේ පන්ති වලට. මට වෙලා තියෙන්නේ ඕකනේ. මම බලලා අමාරුම calculations තමයි කරන්නේ. එතකොට මගේ ළමයි chemistry අත්තරලා physics අත්තරලා combined maths අත්තරලා ඔය හැටක් කරනවා. එයාලට තේරෙන්නේ මේක අමාරු ටික දැම්ම කරගත්තාම ඊට පස්සේ term test වලට score කරගත්තාම ලේසි. term test වල හරියට marks score කරගන්න නැතුව මොරටු engineering කොළඹ medicine යන්න හිතන්න එපා. step by step තමයි වැඩේ කොට දාගන්න ඕනේ. එකපාරටම classes යනවා, ගෙදර එනවා, practice කරන්නේ, complicated questions කරන්නේ, past papers කරන්නේ නැතුව මම කවදා හරි doctor කෙනෙක් වෙනවා, engineer කෙනෙක් වෙනවා කියලා හිතුවා කියලා ඔයාලට එහෙම වෙන්න බෑ. right? මොකද මේක daily practice කරන්න ඕනේ. weekly බලන්න ඕනේ, monthly බලන්න ඕනේ තමයිගේ progress එක. right? ඒ ටික කරගන්න පුළුවන් නම් තමයි පුතාලට ගොඩ යන්න පුළුවන්. හරිම complicated question එකක් recording එක දාන්න recording බලන්න මොකද ගොඩාක් වෙලා යනවනේ ගාන හදන්න හරිම complicated නේ ඔයාලා first time වෙන්නද මේ වගේ ගානක් හදන්නේ ගොඩක් ළමයි ඉතින් ඒක නිසා මේ නැවත බලලා repeat බලලා වැඩේ පුරුදා ගන්න. හරි ටකල් ලියා ගන්න පේනවනේ මට දෙපාරක් විතර erase කරන්න උනා බෝඩ් එකේ ලොකු බෝඩ් එක. ටකල් එක ලියා ගන්න පුතේ next part එකට යන්න. ලේසි වෙනවා practice කරන තරමට තමයි ලේසි වෙන්නේ පුතේ. දැන් මම දැනගත් එකට ලොකු දෙයක් අමාරුයි කියලා ඒකට. ටකලියා කරන part B එකට යන්න. ඔයාලා ඉතින් මේවයි කරන්න ඕනේ. මේව repeat කරලා මට කොහොමද repeat files තියෙන්න ඕනේ class එකට එනකොට theory class එකට. අනිත් අරමුත් මේවා repeat කරලා තමන්ට පුළුවන් වෙනකන් තමන්ට practice වෙනකන් තමයි පුළුවන් වෙනකන් මේවා ආයෙ කරන්න ඕනේ. ඉතින් නැතුව මේවා පුළුවන් වෙන්නේ නැහැ. එකපාරක් මම කියලා දුන්නාට දෙපාරක් කියලා දුන්නට එහෙම පුළුවන් වෙනා නම් අහගෙන ඉඳලා විතරක් KLLs කරලා ડોක්ටර්ස්ලා ඉන්ජිනියර්ස්ලා නේ අඳුරට ගහන තරම් ටොක් කාලා පාරේ හැමෝම ડોක්ටර්ස්ලා ඉන්ජිනියර්ස්ලා වෙන්න. එහෙම වෙන්න බෑනේ. Shall I raise the board? Chemical calculations කියලා කියන්න පුතේ resource book එකේ තියෙනවා වගේ moles equals mass over volume and concentration equals moles over volume or moles equals mass over mole mass කියන දෙක විතරක්ම නෙවෙයි right හරිම චුට්ටයිනේ මේ resource book එකේ තියෙන්නේ but ඔයගොල්ලෝ ගොඩාක් types equations හදනවා දැන් මාස ගාණක් තිස්සේ chemical calculations theory class එකේ අල්ලගෙන ඉන්නේ ගොඩාක් different types ගොඩාක් තියෙනවා ඔයගොල්ලෝ ඉගෙන ගන්න STP equations decomposition impurity samples empirical formula diluted solution ඒ වගේ different equations තියෙනවා different types තියෙනවා ඒ හැම type එකක්ම ඔයගොල්ලෝ දැනගෙන ඉන්න ඕනේ ඒවා practice කරලා තමයි ඔයගොල්ලෝ වැඩේ කොට දා ගන්න ඕනේ එක්කනේ තව classes එකේ මේ paper class එකේ ගොඩක් කරන්න පුතලේ වල්ලක right next B දැන් පුතාලට කියන්න බෑ මේක complicated කියලා එයි දැන් ටෙස්ට් වල අහලා තියෙනවානේ මම කියන්නේ මේ grade 12 first term paper එකක් 2018 දෙවි මේ ස්කූල් එකේ දීවි ඒක බොරුද නැද්ද කියලා පුතාලට check කරලා බලන්න පුළුවන් නැත්තම් ගොඩක් මට එන ප්‍රශ්න තමයි ගිය අවුරුදු වල මේ ටීචර් ගොඩාක් මේ අමාරු ඒවා කරනවා මේ ටීචර්ට තියෙන ස්පෙෂල් ඩිග්‍රී එකක් නේ දන්න කියන ඔක්කොම වර්ණනේ ඔක්කොම දාලා මෙතන වැඩ දාලා අපිව අන්දෝනවා කියලා ගොඩක් ළමයිගෙන් මට කම්ප්ලේන් එනවා ඉතින් ෆස්ට් ටර්ම් ටෙස්ට් එක ලියනකම් එහෙමයි ලියුවට පස්සේ තමයි සද්ද නොකර කටපියාගෙන ඉන්නේ ආනන්ද පුතෙක් හිටිය මගේ 2021 මිනිහා තමයි සෙක්ෂන් ෆස්ට් ඉතින් බැරිම තැන මම කොච්චර කොම්ප්ලිකේටඩ් ඒවා දෙනවද කියලා බැලුවොත් ඒ ළමයා බැරිම තැන මං බයිනවා ඉතින් වැඩ කරන්න ආයෙ නැත්තම් එයා මේ මන් දීපු ටියුට් එකක් ගිහලා ක්ලාස් ටීචර් කෙනෙක් තාලා මේ වගේ වෙනවද කියලා ඊට පස්සේ ටීචර් කියලා මේ ටීචර්ගේ පන්ති දිගටම යන්න පුතේ ඔයාට අනිවාර්යයෙන්ම රෑන්ක් එකක් ගන්න පුළුවන් කියලා ඒ වගේ මේ පුතා රෑන්ක් එකකුත් ගත්තා right ඉතින් අර දරා ගන්න බැරි වුණාම ගිහලා කොයි හරි ඔප්ෂන් එකක් බලනවා මම අමාරු ඒවල දෙන්නේ කියලා හරි B එක බලන්නකො පුතාලා organic compound A contains carbon 48.65% hydrogen 8.11 and rest is oxygen. Find the empirical formula of the compound. Before that, you have to take by considering assumption is by considering 100 grams. So when you take the 100 grams, so percentage masses can convert to grams. So 100 minus sum of these two 48.65 plus 8.11 grams. Then mass can be converted to moles by dividing each from its molar mass. 8.11 grams over 1 grams per mole. Here, I'll use my calculator. 48.65 minus 8.11. Oh, that's 48.65 plus 8.11 minus 100, 43.24 grams over 16 grams per. Then we can take the moles. 48.65 divided by 12, 4.0541. You have to take at least 4 decimals. 8.11. 43.24 divided by 16. 2.7025. Then to take the ratios, divide by simplest number. Simplest number 2.7025. Here 4.0541 divided by 2.7025. 1.500. 8.11 divided by 2.7025 is 3.00. Now you know you can't take the 1.5 as 1 or 2. You can convert this into the nearest whole number if the value is 1.2 or less than 1.2 as 1. If the value is greater than 1.8 or equals to 1.8, so you can convert into nearest whole number as 2. In this case, you have to multiply this by 2. 1.5 into 2 is 3, 2 into 3 is 6, 2 into 1 is 2. So the empirical formula should be C3H6O2. That is the empirical formula. Find the molecular formula, but they have not given the molecular weight. So I should take the molecular weight. Take the molecular weight at 74. Take the molecular weight as 74. Without taking that, you can't take the molecular formula. Right, molecular formula. Molecular formula mass. Into simple N. Sorry. Equals empirical formula mass. So molecular formula mass given as 74 equals C3H6O2 into simple N. 74 equals 12 into 3 plus 1 into 6 plus 16 into 4 into simple N. So simple N will be 74 over 74 as a 1. Therefore, molecular formula also C3H6O2. C3H6O2. Then the question asks, if A contains C double bond O, H group, draw the structure of A. The structure 1, 2, 3. It has C double bond OH. We have totally 6 hydrogen atoms. Already 1 hydrogen atom connected with oxygen. We have 5 more. Give 3 for first carbon, the remaining 2 for the second carbon to complete their valence. So this is the structure. These are the structures. Right. I'll give 5 minutes to get the answer for part C. Part C. Come on, hurry up. Third part also calculation part from the photons energy. Right, unit 1, photons energy. Quantization of energy, quantization energy. First, let the practice how to write the answers for the given questions, right? How to manage time. The first practice with me. After few months, like after 6-7 months, then you can write the papers by taking 3 hours, right? Complete papers. So after starting the paper class, separate paper class, physical paper classes, you can join with physical classes to write the whole papers within the 30 minutes. Sorry, 3 hours. Right here, part C. Solar radiation wave, 325 nanometers wavelength, is bad for human skin. Calculate the following regarding this radiation. Right, the first task, frequency. You know that speed of light equals wavelength into frequency, or frequency into wavelength. Nu lambda. To take the frequency, speed of light divided by wavelength, the speed of light is 3.0 into 10 to the power 8 meter per second divided by 325 into 10 to the power minus 9 meters. We need to multiply this by 10 to the power minus 9 because the meters should convert us to nanometers, should be converted to meters. 3 over 325, 9.23 into 10 to the power 14 hertz or per seconds. Then energy of a photon of a radiation. Energy equals h nu. Planck's constant 6.626 into 10 to the power minus 34 joule seconds. Frequency is, don't write the value you have taken here, because if your calculation is get incorrect, all answers after second part will be incorrect. Therefore, just substitute the values before taking the final answer. It's really better to substitute 3 into 10 to the power 8 over 325 into 10 to the power minus 9. Without substituting the 9.23 into 10 to the power 14. If you got incorrect answer in this step, all answers beyond that will be correct. So 3.0 into 10 to the power 8 meter per second divided by 325 into 10 to the power minus 9 meters. Because at your term test or A-level exam paper, to write the correct units and the correct value, they will give the marks for each step, not the total marks, whole marks for the last step. Right? 3 marks, 3 marks, 3 marks. Totally 9 marks for the substitution. So answer will be 6.626 into 9.23, 6.115 into 10 to the power 3 decimals is enough. Ten to the power minus 20 joules. Third one, energy of 1 moles of photon. Energy of photons given. To get the energy of 1 moles of photon, you need to multiply this by Avogadro constant. Again, don't multiply this value with the Avogadro constant. Write whole answer. 6.626 into 10 to the power minus 34 joule seconds into 3.0 into 10 to the power 8 meter per seconds divided by 325 into 10 to the power minus 9 meters. This is the energy in 1 photon. To take in per mole, multiply this by Avogadro constant. Because to whole marks for this step will be 3, 6, 9, 12. If you substitute incorrect values, the total answer, total marks will be 0. 3.6824 into 10 to the power 6.115 into 6.022. 3.90 plus 23, that is what? 10 to the power 4 joules per mass. Unit joules per mass. Identify the region of the electromagnetic spectrum to which this radiation belongs. In between 400 nanometers to 700 nanometers is the wavelength range for the visible region. Before visible region, there is a UV region, ultraviolet region, wavelength less than 400 nanometers. So the given wavelength is 325 nanometers. Then my classes will so less than 400 nanometers. So the region belongs this is ultraviolet region. Don't write just UV. That should be ultraviolet region. State two uses of this radiation, ultraviolet UV radiations used in spectrometers, techniques, and to identify currency notes. Right, take 5 minutes break and we'll continue fourth question. Paper class කරන එක පුතේ ඇත්තටම අමාරුයි. තීරු ගන්න එක අපිට ලේසි. තීරු ගන්න එක හැම ගුරුවරයෙකුටම ලේසි. මොකද අවුරුදු ගණනක් තිස්සේ දාන්න ටික ක්ලාසස් වල කියන එක පට්ට ලේසි වැඩක්. හරිම ලේසි. දන්නම තීරු ටිකනේ. දාන්න තීරු ටික එකක් දෙකක් එක්සැම්පල් ඇඩ් කරලා ඕවා කියන එක ඉතින් ගුරුවරයාගේ ඇඟේ තියෙන මතකද ගොඩක් ළමයි දන්නා මම නෝට් එකක් බලාගෙන නෙවෙයි ක්ලාස් එකේ උගන්වන්නේ නේ. ක්වෙස්චන්ස් ටියුට් එක විතරයි දෙන්නේ. ඒක අපිට මතකයි. අපි theory ටික දානවා. theory update වෙන්නේ හරි අඩු වෙන්නේ. but calculations කරනකොට papers කරනකොට හරිම අමාරුයි. අපේ සම්පූර්ණම brain එක ගොඩාක් වෙහෙසවන්න ඕනේ. ගානක එක දිගට final answer එක ගන්නකම් ඉන්න ඕනේ. simplifications තියලා theory ටික ගැන ඔක්කොම හිතන්න ඕනේ. ඉතින් ගොඩාක් වැඩ තියෙනවා papers කරනකොට. ඒකනේ papers අමාරු. ඒකනේ level exam paper එක දුන්නාම අමාරු plus level exam paper එකේ research ගන්න අමාරු. බලනකොට first term test ලියුවට පස්සේ ගොඩක් ළමයි එනවා below 20 right term test තාම ගොඩක් schools වල නැතුව ඇති තිබ්බයි තාම marks දීලා නැතුව ඇති තිබ්බත් ඔයාලගේ තියෙන unit 1 එකෙන් එහෙමත් නැත්නම් unit 2 එකෙන් එහෙමත් නැත්නම් unit 1 and unit 3 එකේ first part එක විතරයි එතකොට මේ papers වලත් ලකුණු 30ක් 35ක් 40ක් වගේ නම් ගන්නෙ ඔයාලා හිතලා බලන්න පුතේ lessons 6ක් විතර mix කරලා දෙනකොට කොහොමද ඔයාලගේ ලකුණු නිකන් averagely ඔයාලා හිතලා බලන්න right නිකන් ගන්න පුළුවන් predict කරන්න පුළුවන් නේ අපිට unit 1 එකෙන් ඔයගොල්ලෝ මෙච්චර අඩු මාක්ස් නම් ගන්නේ unit 6ක් 7ක් නේ නැත්නම් 3ක් 4ක් මික්ස් කරලා දෙන කැල්කියුලේට් මේ papers වල term test papers වල කොච්චර අමාරු වෙනද ලකුණු ගන්න කියලා. ඉතින් ස්කූල් එකේදීත් ඔයාලට තේරෙයි subject තුනෙන්ම අනිවාර්යයෙන්ම first term test එකේ ලකුණු 30ට වඩා අඩු වෙනවා. right 30ට වඩා අඩු වෙනවා. හැබැයි ඒක demotivate වෙන්න දෙයක් නෙවෙයි. මම දැන් ඔයාලට කියලා තියෙන්නේ below 30 වෙනවා. ඉතින් ඒක නිසා පුතාලගේ marks වැඩි කරගන්න මේ කරන questions පුළුවන් තාක් practice කරන්න කරපු papers ආයි කරන්න 2 times 3 times නෙවෙයි තමන්ට පුළුවන් වෙනකන් තමයි practice කරන්න. තව පාරක් කරගෙන ඉන්න ඕනේ. අනිවාර්යයෙන් physically ඔයගොල්ලෝ files අරන් ඉන්න ඕනේ. අනිත් දරුවෝ අනිවාර්යයෙන් මේක practice කරලා තමන්ට පුළුවන් දේවල් තමන්ට බැරි දේවල් හරියට identify කරගෙන තමන්ට difficulties තියෙනවා right complicated questions ඒවා හිතන විදිය ඒකට answers ගන්න විදිය theory බලලා patience කරන්න. right ඒක තමයි තමන්ගේ marks වැඩි කරගන්න තියෙන එකම විදිය. Right, take a small break. I'll give 5 minutes and then do the last question. Right, 8:45 now. Start the last question at 8:50. 8:50. Right. I'll give 10 minutes to complete the last question and then I'll discuss it at 9 o'clock. Don't leave. Last question. A successive ionization energy values of elements named A, B, Z are mentioned the following table in kilojoules per moles. Identify the groups above A, B, C, D elements. Briefly explain the reason for your identification. Right, when you take the successive ionization energies for the element A, the first value is 900, second one is 1800, third one is 15,000. So approximately from second to third, 9 times increment. That is huge increment. Therefore, third electron is going from inner energy level. Therefore, outermost energy level of the element A has 2 electrons. Means A belongs to second group. For the element B, 800, 2500, 3600 and 25,000. From third to fourth, again approximately 8 times increment. Therefore, outermost shell has 3 electrons, therefore it belongs to third group. For the element C, 580, 1800, 2800 and 11,000. From 3 to 4, again approximately 9 or 8 times increment. Therefore, it also has 3 electrons, belongs to third group. Then second one, if these elements are in second and third period, identify these elements. So you can see we have 2 elements, both B and C belongs to same group. But B and C starting value is 800, here 580. So down the group, first ionization get decreased. Therefore, the element should be, this is second and third name, magnesium, B, aluminium, C, second and third, hydrogen, helium, lithium, beryllium. Magnesium is beryllium. Boron, aluminum. These are the elements. Write the chlorides formed by above A and B elements and state their geometric shapes. State the hybridization of each element. So, chloride formed by beryllium is BeCl2. Geometry linear. BCl3 geometry trigonal planar. AlCl3 also trigonal plane. Hybridization is P. Here is P2. Here is P2. Marks to identify groups 5 into 315. To explain the reason, another 15 totally 30. To identify the elements 5 into 3 15. Linear and shape hybridization 2 into 6 12 marks. Right. Then B. Ammonia, CCl4, CH3CH2OH, CHCl3, argon, H2S, ammonium chloride, H3O plus, and magnesium chloride. Which of the above substances contain following secondary interactions? Dipole-dipole interaction present in CH, Cl3, H2S. Right. Then hydrogen bonds, ammonia, ethanol, and H2O plus. London dispersion forces, CCl4, argon. Fourth one, dative bonds present in ammonium chloride and H2O plus 2. Fifth one, ionic bonds, ammonium chloride and magnesium chloride. So each answer scale 3 marks. 11 into 3, 33 marks. 33. Then arrange magnesium nitrate, calcium, strontium, barium in the increasing order of decomposition temperature. Explain to answer. In associated with polarizability. So, increasing decomposition down the group. So, highest one, lowest one, magnesium nitrate, then calcium nitrate, strontium nitrate, barium nitrate. So explain your answer, not polarizability, polarization. So you have to write for this answer 5 marks. Then you have to write all have same anion, therefore same polarizability. Same anion, same polarizability. Same anion, same polarizability. But charges of cations are same, radius of cations are different. Radius of cations increases as Mg2 plus as lowest than Cl2 plus, strontium 2 plus, and barium 2 plus. Magnesium 2 plus as lowest than calcium 2 plus, strontium 2 plus as greater than calcium 2 plus, highest than barium 2 plus. When ionic radius, cationic radius get increased, polarization power decreases. When polarization power decreases, covalent properties decreases, ionic properties increases. Increase in ionic properties goes to increase thermal dissociation temperature. For the explanation, 10 marks. You have to list all points. Next one. Deduce the geometrical shape of the following ions using Welsper theory. Here PO4 3 minus phosphate. This is the Lewis structure. Then NO2 minus. Then ICl2 minus. So first you have to write the central atom. Central atom is phosphorus, nitrogen, and iron. Surrounding atoms are oxygen, chlorine. Total number of valence electron, phosphorus 5, oxygen 6 into 4. Here nitrogen 5, 6 into 2, 4 oxygen. Iodine 7, 7 into 2, 4 chlorine. Then electron pair 6 into 4, plus add 3, right? We need to add 3 here. So total 6 into 4, 24, 24, 27, 5, 32. To take the pairs, divide by 2, 16 pairs. And not to minus, you have to add 1. 6 into 2, 12 plus 13 plus 5, 18. 18 divided by 2 to take the pairs, 9. Then you have to add 1, 22 to take the pairs, you have to divide by 11 to the 11 pairs. Then after drawing the table of structures, you have to write the central atom as 4 whispers, 0 lone pairs, therefore tetrahedral shape. For this one, 3 whispers, 2 bonded whispers, 1 lone pair, therefore trigonal planar is a geometry, shape is angular. For this one, total whispers are 5, 3 is lone pairs, 2 is bonded whisper pairs, therefore the geometry is trigonal bipyramidal, shape is linear. Five into 3, 15 marks. $120. Right, the last one, I'll give 3 marks for those parts because in my class 2, still I haven't completed redox balancing. I'll give 3 marks for that and D2. So total 3 marks is 30. Put the marks out of 150. For the first part, total marks out of 100. For the second part, out of 150. For the third part, again 150. Put the marks totally out of 400 and multiply by 100 to take as a percentage value. Please repeat the questions, right? Repeat and practice. If anyone wants recordings, you can take the recordings, right? Send a private message to take the recording. Right, so we'll continue next Tuesday. Thank you very much, Putala. Good night, good night.